Spotify has risen to become the undisputed heavyweight of the music streaming industry. In 2021, they announced they had reached over 400 million global users, and at every turn, they're beating their competitors in terms of subscriber count, other tech giants like Apple, Amazon, and Google. So why is Spotify so good at what it does? Spotify employs a robust recommendation engine, allowing users to get more of the music that they like faster. How is Spotify able to do this? Data, and lots of it. We're talking hundreds of data points per song, thousands per album. A playlist is a statistician's dream. Our application is called Spotify Journey. The idea? Take a snapshot of a Spotify playlist and be able to create data visualizations using D3, a powerful library purpose-built for displaying data. So, how does it work? Let's take a look. It all starts with Spotify's API, the source where we're able to gather data about a given playlist and all the songs within it. Spotify's API acts as the bridge between their database and us and many other developers who want access to Spotify's wealth of information. However, there's a catch. Spotify's API uses what's called a rate limit. Essentially, we can't make too many requests for data within a certain time frame, or Spotify will start rejecting those requests. In the event that the rate limit is hit while a user is using the application, user would be prevented from using it, as Spotify's data is the key. Without it, we have no visualizations to show. To get around this, we use our own database and pull Spotify's data into it as needed. When we need to access it, we query our local database. This ensures that we have access to the data that we need when we need it. However, the database also stores other important information, like login information for users, as well as the associations between users and their playlists. Next, we use our own API, written in JavaScript and utilizing Koa and Axios, two libraries which help us bridge the gap between our database and application, helping us to get our data in a digestible form for D3 and ready for visualizations, as well as retrieving and validating a user's login information. Finally, we have the application itself. Written in JavaScript, it utilizes React, Meta's extremely powerful web framework, as well as a variety of other libraries such as MUI, and of course, the star of the show, D3. Let's give the application a look. We start at the main splash page. Clicking Begin Your Journey will bring us to the login page. Let's log in with an existing account so we can view some playlists. Logging in brings us to the main profile page, which has some information listed about what we went over earlier, relating to how we get the data from Spotify and turn it into visualizations. On the top left, we can click on the Home button to view all the playlists associated with a given account. Let's take a look at the first one here. Our data visualizations are divided into modules, all of which are listed along the top of the page here. We can click any of them to jump to that visualization. Using the button in the bottom right, we can jump back to the top of the page. The top summary section features a Spotify embed for the entire playlist. We can scroll through it and view the playlist at a glance. While we can jump to sections on an individual basis, the easiest way to get the most full view of a playlist data is simply to scroll. All the visualization modules are self-contained within a single page. Scrolling down to our first visualization, we've broken up the songs by decade. It looks like the most prevalent decade for this playlist was the 2010s. Based on the decade, we can then show the user what song spent the most weeks in the number one position on the top 100 Billboard chart during that decade. In this case, it's Uptown Funk. We can click play on this embed and hear a sample of the song. Let's keep scrolling. As we do, we'll get more and more of these previews pertaining to different extrema of the data. Here we get the oldest and most recent songs. The next metric is popularity. Spotify assigns a popularity value to each song based on the number of listens it receives and how recent those listens are. Generally, a popularity score of 70 signifies that a song is popular. Here we can see, based on this chart's data, that this playlist has songs that are generally more obscure. Its lowest song has a score of 7, while its highest only reaches 50. Scrolling even more, we can see a quiz, which pits two songs against each other, where we can guess which is more popular. Our win rate is tracked. Here we only got 55%, but it's okay. We'll just keep going. Scrolling even more, We can see a visualization based on the length of the songs, but the conclusions we can draw from it are pretty standard. So let's keep going and move on to a more interesting visualization. Songs broken down by genre. Part of what makes Spotify's recommendation engine so good is the fact that it assigns such specific genre tags to songs. In fact, many genre tags only appear once or twice, hence the large section of the pie chart labeled Other. This top embed here has no genre tags associated with it. This is because Spotify doesn't run genre analysis on a song until it becomes sufficiently popular enough, meaning that this song likely has a low popularity score. The next visualization is a scatter plot showing the relationship between energy and valence. Energy is a measurement of how fast and regular the beat of a song is, while valence is a measurement of happiness, with a higher valence corresponding to a happier song. Any clustering in the top right of the graph shows the correlation between happier songs being generally more upbeat. Let's give a listen to the lowest and highest energy songs and see if we can tell the difference. Scrolling down, we reach a visualization about explicit language, but see something interesting. None of the songs on this playlist have lyrics. Let's switch to a different playlist. Now, we've switched to a playlist which has songs that have lyrics. The left pie chart is the data for this playlist, while the right is the data for the 100 most streamed songs on Spotify. You can see that this playlist is generally less explicit than that. We've also reached the All Songs section, which lets us see a preview and a beautiful Spotify embed for each track. Scrolling through these, we reach the Song Selector, which allows us to select any specific song from the playlist and view its raw values. Finally, we've reached the end. We can navigate back to the top of the page and log out. We really hope you've enjoyed our presentation. Thanks for watching.